Today you will be learning how to solve nonlinear systems of equations. As you see in this system of equation, it has a quadratic equation and a linear equation. So we will be learning how to solve those types. When I see this equation, the first thing I notice is that the start value is the same, y is equal to that, and the y is equal to that, and the end value is the same, -3 and -3. And there's only one thing left, a variable multiplied by something else. So that means, theoretically, if we put 0 as x, then we can just get rid of x squared and we can get rid of 2x. And that gives us y is equal to -3. And then if we put 0 there, x is equal to 0. So one of our solutions would definitely be, it would be 0 comma -3. Okay, so our first solution is 0, -3. And again, I pointed out that the start value is the same. Y is equal to something, and y is equal to something. So that means, since y is equal to y, x squared minus 3 is equal to 2x minus 3. So here we can eliminate -3 from here, -3 from here, and then, because we're adding 3 to both sides, so then we get x squared is equal to 2x. If we divide this whole equation by x, then we get x is equal to 2. So then if we take x is equal to 2, enter that in the original equation. We can take either one of them. I'll take the first one. Y is equal to 2 squared minus 3. Y is equal to 4. 4 minus 3. Y is equal to 1. So our second solution would be 2 comma -1. Oh no, 2 comma 1. There's no negative in this one. 2 comma 1. Okay, let's get into some practice problems. Okay, for the practice problems, let's take y is equal to 2x and y is equal to x squared minus 3. And then we'll take oops, not the wrong color. Then we'll take let's do y is equal to x minus 3 and y is equal to x squared minus 5x plus 6. Okay. Pause the video if you want to try to solve them. Let's get into the solutions. Okay, in the first one, do the same thing. We can do the same thing for the first one. We can equate them. 2x is equal to x squared minus 3 because y is equal to y. So then, we can just say 0 is equal to x squared minus 2x minus 3 because we're subtracting 2x from both sides. And now we have a quadratic equation. So let's use the product sum method to factor this, to find the roots. product sum. So two numbers that multiply to -3 are 1 and -3, and they also add sum to -2. So then we can rewrite the equation as, after all the algebra, we'll get x minus 3, x, x plus 3, or x minus 3, x plus 1. And then at the roots, we'll get x is equal to 3 and x is equal to -1. So that means for our two equations, the starting values are -1 and 3. So then if we substitute -1 in the first equation, we have y is equal to -2. So -2, and then 3 into our first equation is, we get 6. Okay, for the second one, same thing, we can do x minus 3 is equal to x squared minus 5x plus 6. Then we could say 0 is equal to x squared minus 6x, because we're subtracting the x from both sides, plus 9 because we're adding the 3 to both sides. Now we immediately notice that this is a perfect square. It's a perfect square of 0 is equal to, it's a perfect square of x minus 3. So that means our x is equal to 3. And there's no other solutions. So our solution will be 3, comma, so we have to substitute 3 back into the original equation. 3 squared, or let's do y is equal to x minus 3. 3 minus 3 is 0, so 3 comma 0 is our solution for the second one. That's it.